Okay, today's lesson is going to be pretty short. What we're talking about today is phase change diagrams and how to read them, and then how we can use them to figure out where and when something will change phases. So this one right here is a pretty generic example of a phase change diagram that you can see on the screen. These lines going through it are the points where this substance, whatever it is that's being represented here, is changing between the different states of matter. Right? So every chemical will have its own phase change diagram that'll have a different shape and different points where these lines intersect. But the main idea is that in the top left hand side, where the pressure is high and the temperature is low, is where the substance is going to be a solid. The bottom right hand side, where pressure is relatively low on your y-axis and temperature is high, is where the substance will be a gas. And then in between those two is where it's going to be a liquid. The lines that you draw between them are where it transitions between the two of those with respect to the pressure and the temperature that the chemical is at. So you can see if we keep our pressure constant and start somewhere around here where my mouse is, keep our pressure the same and raise our temperature, it behaves just like you'd expect, right? It goes from a solid. As the temperature raises, eventually it crosses this line here and becomes a liquid. And then if you raise the temperature even higher, it'll start to boil and become a gas. Right? This also can give you the relationship of how phase change works when the pressure is changing. So you guys might have heard that like at higher altitudes, water boils at a lower temperature. You have to boil things for longer to cook them. So that's because if you keep the temperature constant and your pressure increases, temperature stays constant and your pressure decreases, so we're going from a high pressure down to a low pressure, you can transition between liquid and gas. So you can see how it would boil at a lower temperature when the pressure is lower. So a couple of important points on this graph that you guys need to know are what's called the triple point here. And this is where all three of these lines denoting the phase changes meet up. And at this point, you can have all three states of matter visible at the same time. All right, the other important point is up here, the critical point. And this is the point where if you have a higher pressure or a higher temperature than this point, the states of matter become a little more fluid, and things aren't really definable as either a liquid or a gas. They're kind of somewhere in the middle. So you can see this line between them doesn't extend farther out here. In any area beyond this critical point, we call it a supercritical fluid, is what the state of matter is. But really, we don't have to worry too much about that weird state of matter out there, because that's only at very high pressures and very high temperatures that we'll never run into in real life. All right, one extra thing that you guys may not have seen before, or don't remember if you have seen it before, this transition between melting and or solid and liquid is melting and freezing. That's pretty common, right? Between liquid and a gas is vaporization and condensation. So hopefully you guys have heard both of those terms before. The other word used for it is boiling and condensation, but they mean the same thing. But between a solid going straight to a gas without going through a liquid first is a less common transformation. So if you're not familiar with those terms, the term for going from a solid straight to a gas is sublimation. And then from a gas back to a solid without becoming a liquid first is deposition. So keep those two in mind, because we are going to see those when we do our demonstration later with the dry ice. Okay, which brings us to this graph right here. So this graph is the phase change diagram for CO2, which is it's the substance we breathe out, carbon dioxide. It's also what dry ice is made of. Okay, this is going to be a little hard to read because our scale here for pressure is so high. But bear with me and we'll figure it out. the main idea here is that when we see dry ice, the reason it's called dry ice is because it doesn't go through this liquid phase, right? At pressures that we are generally experiencing, which is, very close to 1 atmosphere way down here, the transition between dry ice as a solid and CO2 as a gas is what we'll be witnessing. It doesn't come up here all the way up to above 5 atmospheres to transform into a liquid before it goes into a gas. It just goes straight from solid to gas, because everything that we experience commonly in the Earth's atmosphere is down here in this very low section of the graph. So you'll see that if you just put dry ice out, on the table in a bowl or whatever, it goes straight to a gas, doesn't make a liquid. It just turns into that steam that they use at Halloween parties and stuff. All right, what we're going to try and do for our demonstration is observe this triple point where we can see the solid dry ice, the steam coming off of it, the vapor, and then also a little bit of the liquid dry ice. Right, and so the way we're going to do that, and I'll show you guys that are in person here in a minute, is if you take some of the dry ice and you put it inside a pipette and then clamp the end of that pipette down so no air can escape. As it heats up, the pressure will build up inside that pipette because there's nowhere for that extra volume of the vapor CO2 to go. So pressure builds up, temperature increases, and eventually we get to this 5.11 atmospheres where we can see the liquid CO2 being formed, as well as there still being some of the solid and some of the vapor. All right, so that's what we'll be looking for during our demonstration. The other thing that we obviously won't see in class is this critical point, because getting anything up to 72 atmospheres is very dangerous. That's like in the range of 1,000 psi. So that's nothing that we're equipped to work with. But you need to be able to recognize the critical point on the graph as the point where things stop behaving like a regular liquid or a regular gas. Okay, so this is your main assignment for today, is the homework assignment over phase change diagrams. And then make sure you've gone back and finished all of the other thermochemistry stuff, because we're going to be having a test on it at the end of the week.